Hello, my dear students. How are you all? I am fine. I am Khandakar Fazda Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important creative question from chemistry second paper, chapter 3, quantitative chemistry. So let's we start our online chemistry class. My dear students, now I discuss with you some important creative question from chemistry second paper, chapter 3, quantitative chemistry. Our first system is here given solution A 1% sulfuric acid 200 ml and solution B sodium hydroxide 300 ml decimolar solution. That means the molar concentration of sodium hydroxide is 0.1 molar. So our first question is what amount of 1.825% hydrochloric acid solution is needed to neutralize 20 ml B solution. So, my dear students, to solve this question, at first we have to know the concentration of hydrochloric acid. So, our first step is concentration of 1.825% HCl solution. We know that the formula of concentration is S equal to W into 1000 divided by mv. Here given 1.825%, that means W equal to 1.825 gram, volume V equal to 100 ml, because here given percentage, and molecular mass of hydrochloric acid is 36.5. So, my dear students, concentration of hydrochloric acid is W 1.825 into 1000 divided by 136.5 into 100. We can say that the concentration of hydrochloric acid is SA because HCl is an acid, and we get the concentration is 0.5 molar. Now, my dear students, here the reaction occurs like this: HCl plus sodium hydroxide reacts and we get sodium chloride plus water. So, if concentration of here concentration of HCl, that is SA, equal to 0.5 molar, volume of HCl VA equal to what, and concentration of sodium hydroxide is B, because this is base, that is 0.1 molar. Why 0.1 molar? Because the given concentration of sodium hydroxide, that means B solution, is decimolar, and volume of sodium hydroxide, that is Vb, equal to 20 ml. Now we get, my dear students, VA SA equal to VB SB. So what is VA? Equal to VB into SB divided by SA. What is the value of VB? That is 0.1, value of VB, that is 20 ml, 20 into SB, 0.1 molar, 0.1 molar, and concentration of hydrochloric acid, that is SA, is 0.5 VA, or we get the answer is 4 ml. 4 ml. So, my dear students, to neutralize 20 ml B solution, so my dear students, to neutralize 20 ml B solution in 4 ml HCl solution. My dear students, our next question is question number D. What will be the nature of the mixture if A and B solution are mixed together? Analyze this mathematically. So, my dear students, here given 1% sulfuric acid 250 ml and sodium hydroxide 300 ml decimolar solution. So, to solve this question, at first we have to know the molarity of sulfuric acid. That means molar concentration of sulfuric acid. Concentration of 1% sulfuric acid, H2SO4. We know S equal to W into 1000 divided by mv. Here W equal to 1 gram, volume V equal to 100 ml, molecular mass of sulfuric acid is 98. So, W 1 into 1000 divided by 98 into 100, and the answer is 0.1020 molar. So, the concentration of 1% sulfuric acid is 0.1020 molar. Now, my dear students, to convert the concentration into 1 molar, we write 250 ml, 0.1020 molar H2SO4 equivalent to 250 into 0.1020 ml, 1 molar H2, 1 molar H2SO4. That is, we get 25.5 ml 1 molar sulfuric acid H2SO4 solution. But this is here in sulfuric acid 2 hydrogen is present. So, we write 2 25 sorry 25.5 into 2 ml 1 molar H plus solution. Okay, my dear students, we get here 51 ml 1 molar H2SO4 solution. Now 300 ml 0.1 molar sodium hydroxide solution equivalent to 300 into 0.1 ml 1 molar NaOH solution, and we get here 30 ml 1 molar sodium hydroxide solution. So, my dear students, here the reaction occurs like this: H2SO4 plus 2 sodium hydroxide equal to Na2SO4 plus 2 H2O. That means hydrogen ion reacts with hydroxyl ion and neutralize by producing water. This reaction occurs if A and B solution mixed together. My dear students, here the reaction occurs like this: 1 mole sulfuric acid reacts with 2 mole sodium hydroxide and produce sodium sulfate plus 2 H2O. The main reaction is hydrogen ion and hydroxyl ion, and it produces water. Okay. Now, if we mixed these two solution together, then after reaction we get excess hydrogen ion. That means after reaction excess hydrogen ion solution equivalent to 51 minus 30 ml 1 molar H plus solution, and we get here 21 ml 1 molar H plus solution. And to convert this H plus solution again in sulfuric acid solution, we have to divide this 21 by 2. That means 21 divided by 2 ml 1 molar H2SO4 solution, and we get the answer is 10.5 ml 1 molar H2SO4 solution. Here we see that in the mixture 10.5 ml 1 molar sulfuric acid solution remains. So, the nature of the mixture is acidic. So, the nature of the mixture is acidic. Now we calculate the concentration of the mixture. Concentration of the mixture. At first we write here V1, that is the excess sulfuric acid remains in the solution, that is 10.5 ml, and S1, that means concentration of this sulfuric acid, is 1 molar, and V2 equal to the total volume of the mixture, that is 250 ml plus 300 ml, and we get 550 ml. 550 ml. And what is the concentration? That means S2 equal to what? My dear students, we know that we get V1 S1 equal to V2 S2. So S2 equal to V1 S1 divided by V2. That means S1 equal to V1 equal to 10.5 into S1 1 divided by V2 equal to 550. So the answer is 0.19 molar. So we can write concentration of the mixture is 0.19 molar. My dear students, now I discuss with you our next creative question. Here given sample, reagent and indicator. Sample 1, determine the concentration of 100 ml sodium hydroxide by 10 ml 0.1 molar hydrochloric acid. In this reaction, any indicator can be used. Sample 2, determine the concentration of ammonium hydroxide by 0.1 molar hydrochloric acid, and here we use methyl orange indicator. And sample 3, determine the concentration of sodium hydroxide by 0.1 molar acetic acid. Here we use phenolphthalein indicator. Now question number C. Our first question, calculate the concentration in ppm by the base of sample 1. So here the base is sodium hydroxide, and the given volume of sodium hydroxide is 100 ml, and acid is hydrochloric acid, and given volume of hydrochloric acid is 10 ml, and given concentration of hydrochloric acid is 0.1 molar. Now we have to calculate the concentration of sodium hydroxide in ppm unit. My dear students, solution question number C. Here let concentration of HCl, that is SA equal to 0.1 molar. Volume of hydrochloric acid, that is Va, equal to 10 ml. Now, volume of sodium hydroxide, Vb, equal to 100 ml, and concentration of sodium hydroxide, that is Hb, equal to what? My dear students, here the reaction is hydrochloric acid plus sodium hydroxide, and it produces sodium chloride plus water. Here we see that 1 mole HCl reacts with 1 mole sodium hydroxide. So, we get VASA equal to VBSB, and for SB equal to VASA divided by VB. So, we write here 10 into 0.1 divided by 100, and the answer is 0.01 molar. Now, my dear students, we have to calculate this molar concentration in ppm unit. Now, to convert molar solution into ppm unit, we have to multiply the molecular mass of the compound and 1000. SB equal to 0.01 into molecular mass of sodium hydroxide, that is 40, and we multiply here 1000. Then we get the unit is milligram per liter. Okay, the answer is 400 ppm, because milligram per liter is the unit of ppm. So, we can say that the concentration of base in ppm unit is 400 ppm. My dear students, our next question is according to the STAM, that means according to the STAM, in titration different indicators are used and analyzed. Here we see that we can use any indicator. For sample 1, we have to use methyl orange. For sample 2, and we have to use phenolphthalein for sample 3, and this is the question, that is in titration different indicators are used. My dear students, now we discuss about the question number D. Here in sample 1, here we use hydrochloric acid and sodium hydroxide. Sodium hydroxide is a strong base and hydrochloric acid is a strong acid. The change of pH has been represented by the graph during titration of strong acid and strong base. It has been seen from the graph that if strong acid is added dropwise into strong alkali solution, first the pH value gets increases gradually, but the pH of the solution near the neutralization point become 3 from 11 by getting reduced suddenly. The solution becomes completely neutralized just after adding small amount of hydrochloric acid to the solution, means the pH of the solution changes suddenly at quicker rate. It is noted that within the range, this range, the graph in the linear shape, this is linear shape, the indicator which changes the color within the pH range suitable for used as indicator, that means 3 to 11 pH range. Basically, any type of indicator can be used in such case, that means for a strong acid and strong base titration we can use any indicator. My dear students, here for sample 2 we use ammonium hydroxide and hydrochloric acid. My dear students, we know that hydrochloric acid is a strong acid and ammonium hydroxide is a weak base. Titration of strong acid and weak base, the aqueous solution of salt produced from strong acid and weak base is slightly acidic. For this reason, pH is below 7 at the end point. If solution of strong acid is gradually added in the solution of weak base in the near point, that means end point, the indicator that changes color change from 4 to suddenly. So, the indicator that changes color at a pH range 4 to 7 are used in titration as strong acid and weak base. Here we see that the pH range of methyl orange is 3.1 to 4.4. So, for this type of titration, that means strong acid and weak base, we use methyl orange. My dear students, now we discuss about sample 3. Here we use sodium hydroxide and acetic acid. We see that acetic acid is an weak acid and sodium hydroxide is a strong base. Here given the graph of this titration reaction, we see that if we add sodium hydroxide gradually, the pH changed, that means increases, and near the point of 6, if we add another sodium hydroxide solution or gradually added sodium hydroxide solution, then the pH shifted to nearer 6 to 11. So, we have to use that type of indicator which can change color by this range. And for this type of titration we have to use phenolphthalein, because phenolphthalein change its color from 8.3 to 10 range pH. So, my dear students, I think that you can understand why we use different type of indicator in this different type of sample.